Let's take a look at structural design. I'll try to help you with notes so you know when to write some things down. So let's start here. The first thing I want you to note down is a primary function, and it is to support and transmit the building loads to the ground. So you are supporting and transmitting the building loads to the ground. That is the structure of the building. Supporting the loads and transmitting them to the ground. So please note that down. Here's a neat little building. All right, so 3 characteristics of a structure. I'm just going to read these off for you, so just listen in. You'll probably want to note at least these 3 words. Strength is just capacity to carry the loads, how strong it is. Stability is its ability to keep them from falling over. And economic value, it really depends on the materials that you choose and the structural systems that you use to make it economical. You can make a structure strong enough to withstand pretty much anything, but it's going to be really expensive. So economic value is important that you don't over-engineer it. Structural systems. Structural systems, and just pause for a second, just listen to this, are made up of many smaller structural subsystems that work together to provide a strong, stable, and cost-effective structure. So what I would like you to note down are the examples, smaller structural subsystems that make up a full structural system. So these are some smaller structural subsystems: roof, walls, floors, framing, and foundations. And structural engineers will design all of these structural systems. So these are things that structural engineers will design. So it is important to note those 5 items. These are some subsystems. So if you're going to make a roof, you need to have trusses. So a roof is made out of trusses. That's a subsystem. It's just an example there. They are made up of many structural elements that work together to provide a strong, stable, cost-effective system. So the 6 things you should note down for structural subsystems are beams, column, trusses, and then arch, vault, and dome. We've talked a little bit about arch, vaults, and domes, and I'm going to go into detail on each one of these. So after you write these down, then you can be prepared to add a little bit more onto each one of them. Force is any action that causes a change in shape or motion of an object, and a load is a force that is supported by a structural element. So in structural engineering, the terms force and load are often used interchangeably. Force, load, force, load. Here are some forces. So these 3 you definitely want to note down. These are really important, especially for the bridge unit that we're going to be doing next. Tension is pulling apart. That might be all you need to write down. Compression is squeezing together. And shear is when forces act on opposite sides. So it's causing particles to slide on each other. So take a moment, you can pause this and read through these definitions, but you can make them as short as what I said: pulling apart, pushing together, and then sliding against each other. All right, beam. So now back up to that word you wrote above, beam. Don't need to write all of these things down. Just listen in for a second. It's a structural element that carries a load that is applied transverse or perpendicular to its length. So you can see it's applying the load perpendicular to the length. The load goes down, but the length is left to right. So a beam is usually horizontal, and that's kind of one big thing. So note, beams are horizontal, and the second thing to probably note is that the top fibers of the beam are in compression, the bottom are in tension. You note when this beam bows, because we have Samuel and Jack and then his son, you can notice that the top ones, when it bows, these have to be squished together and these have to be pulled apart. So beams undergo compression and tension at the same time when they have loads applied to them. Okay, here's a cantilever beam. So a cantilever beam is just supported on one end. So add that to your notes. Under beam, cantilever beam, supported on one end, and top fibers are in tension, bottom are in compression, which is the opposite of a standard beam that's supported on both ends. So note the difference. Again, you don't have to write all of the things down. Just pick out the parts that are significant. Column is a vertical structure that carries force and compression. So columns are always in compression, and it's vertical. Columns vertical and in compression. A truss is a structural element that is composed of smaller structural members, typically configured in triangular arrangements, almost always in triangular arrangements actually. Some trusses are in tensions, others are in compression. So if you look at this one here, we have these are in compression, and that causes these on the bottom there to actually be spread apart. They're under tension. And you're going to take a look at different truss bridges in this next unit and identify which are in compression, which are in tension, and that's going to really play a significant role in the bridge you design. All right, here is an arch. So an arch is just a curved element that spans over an open space. You already know a little bit about arches, so if you don't need to add anything because you feel like I got this down, then good for you. All right, the top piece is the keystone, and that's usually the last place put in if it's a stone arch. Then a vault is just a continuous arch that slides all the way along. A dome is just an arch that's rotated around. So it's a bunch of arches inside here rotated around to form a half sphere. And hybrid forms, there's lots of different options in hybrid. You can make lots of different combinations of things. These are like sort of truss-like structures that are all kind of making a dome. So hybrid just means you can make lots of different things.